Now let us discuss the photon flux due to a point source of light. We know if we are given with a point source of light and say it is of power p watt, that implies it emits light photons isotropically in all directions uniformly, and in three-dimensional space in its surrounding, the power emitted is p watt, that is p joule energy is emitted per second. And in this situation, if we calculate the total photons emitted per second, this is given as p lambda by hc, which we already studied. And these are emitted in a spherically outward direction, like here you can see the situation. And in this situation, at a distance x from the source, if we consider a point A, then at this point we can see the whole power P is crossing through this sphere, which we can see in this situation. And from this spherical region, if the total power P is emitted, then we can directly write the photon flux in this situation is the amount of photons which are passing through per second per unit area from this surface. Say on this surface, if we consider a small section of 1 meter square, then we can directly state that number of photons passing through this 1 meter square will be equal to phi p is equals to p lambda by hc divided by the total area of the spherical region. Then only it will give us the number of photons passing through 1 meter square. So there's 4 pi x square. So here phi p can be written as again as p by 4 pi x square is intensity at this point A. It can again written as I lambda by hc, or it is p lambda by 4 pi hc x square. This is the way how we calculate. And intensity at point A can be given as this power per unit area, this p by 4 pi x square. This is the intensity at point A, that is the amount of energy passing through unit area in 1 second. So this is the result we use for the photon flux at a distance x from a point isotropic source of power p watt.